Yo, Leonard, what are you doing, dude?
I got it! Mathematical beauty right there!
That was Leonard Euler, discovery of Euler's identity. Euler's identity is a special case of Euler's formula from complex analysis, which states that for any real number, x, e to the power of ix equals the cosine of x plus I times the sine of x.
When you plug pi into the slot of x in the starting equation, the equation becomes e to the power of I pi equals cosine of pi plus I sine pi, where cosine of pi equals -1 and sine pi equals 0, so that e to the power of I pi equals -1 plus 0i, which yields Euler's identity, e to the power of I pi plus 1 equals 0. Skrrr.
Euler's identity is often cited as an example of deep mathematical beauty. Three of the basic arithmetic operations occur exactly once each: addition, multiplication, and exponentation. The identity also links 5 fundamental mathematical constants. First, the number 0, right there. It is the additive identity, because if you add it to something, nothing happens. 1, the multiplicative identity, because if you multiply something by 1, also nothing happens. Pi, a number which is ubiquitous in Euclidean space and analytical mathematics. E, the base of natural logarithms which occurs widely in mathematical analysis. For example, e equals 2.718 and so on. And finally, I, the imaginary unit of the complex numbers. A poll of readers conducted by the Mathematical Intelligencer in 1990 named Euler's identity as the most beautiful theorem in mathematics. In another poll of readers that was conducted by Physics World in 2004, Euler's identity led with Maxwell's equations of electromagnetism in The Greatest Equation Ever. A study of the brains of 16 mathematicians found that the emotional brain, specifically the medial orbifrontal cortex, which lights up for beautiful music, poetry, or pictures and all, lit up more consistently for Euler's identity than any other formula. The exponential function e to the power of z can be defined as the limit of, in parentheses, 1 plus z over n to the power of n, as n approaches infinity, and thus e to the power of I pi is the limit of 1 plus I pi over n to the power of n. In this animation, n takes various increasing values from 1 to 100. The computation of 1 plus I pi over n to the power of n is displayed as the combined effect of n repeated multiplications in the complex plane, with the final point being the actual value of, in parentheses, 1 plus I pi over n to the power of n. It can be seen that as n gets larger, in parentheses 1 plus I pi over n to the power of n approaches a limit of -1. Oh, hey, didn't see you there. I'm Stanford professor Keith Devlin, and I think Euler's identity is like a Shakespearean sonnet that captures the very essence of love, or like the human form that is far more than just skin deep. Euler's equation reaches down into the very depth of existence.
Hello, I am the mathematics writer Constance Reid, and personally I think that Euler's identity is the most famous formula in all of mathematics.
Hi there. I'm Benjamin Pierce, a noted mathematician and philosopher from the 19th century. I once said in a lecture, Euler's identity is paradoxical. We don't know what it means, and we can't know what it means. But we have proved it, so therefore we know it to be the truth. So, we chose Euler's identity because when we were looking at our 3 research things for our research project section, we saw the words mathematical beauty, and that really drew me in, because I didn't know what that was. Take it away, Reid.
Yeah, so Euler's identity, we were kind of interested because, we didn't know what it is. We didn't really know that existed. So we thought it'd be interesting to kind of just, explore that topic and, see what it was about, you know?
Yeah, and I think we learned a lot from this. We've learned the cosine and sine of pi equals 0 and -1.
And also just, more about, a new topic to us, so...
Yeah, Euler's identity is pretty cool. I think mathematical beauty is something that will affect my life greatly in the end.